Hello everyone, I'm again back with the second part of this tutorial of this Gaussian dispersion model. Pardon me. So till now we have discussed what is a crosswind direction, what is a downwind direction, and what is a vertical direction. So based on this concept, we'll move further ahead with this discussion and we'll see how the numerical works and how to actually decipher a certain elements to solve the numericals related to these things. Okay. Now the part of the chalks and these things are over, so I can just safely put it back to where they belong. Yes, hand sanitizers, of course. Yeah, fine. Anyway, so we have a sigma y component over here, a sigma z component over here, and I have missed out on this on the PDF file also. There should be a z direction over here because it's x, y, and z is missing. X represents the downwind one, y represents the crosswind one, and z represents the vertical distance, as you can see from here. Now, how to find out the sigma y, sigma z, this u, q, etc. These and that things. Okay. Before that, I'll need to explain a little bit about y, because q I need not explain because nothing is there to explain over here. And in u, you have a mean wind speed, as you can see from here. A mean wind speed. A mean wind speed is actually denoted by this very formula. If you remember in the irrigation and not irrigation of water resource, it was in engineering hydrology, we had a potential evapotranspiration. Yes, PET. So out there we have encountered these U values over there. Now out there was a certain different power or exponent over here. In this case, it's nothing but u naught by z, u naught into z by z naught whole to the power 1 by 7, where u naught is the wind speed at ground level, z is the stack height, the height of this very thing, and z naught is actually the anemometer height at which the anemometer is present. Anemometer means the device which measures wind speed. Generally, it is kept at the zero level. Hence, it is denoted by z naught and also u naught. Okay. X, Y, Z and sigma y, sigma z. Now, sigma y, sigma z, I cannot tell you or I cannot explain you in this very graph. For this, we need to have a numerical against it, but I can definitely explain a little bit of that in this very graph. Now, see, observe this very, very, very carefully. Now, a wind is blowing in this direction. As you take the reference of this very figure, a wind is blowing in this very direction, isn't it? In this very direction the wind is blowing. That means along the x-axis. Now use your imagination power and imagine in which direction this smoke is going to disperse. Now when I'm telling you dispersion, do not jumble it up with propagation. Propagation means the travel of the smoke. Dispersion means the spreading of the smoke. Now the smoke is spreading in this direction and in this direction. The smoke is spreading along this and also along this. So the spreading is happening in these two directions. One is in this direction, as you can see, the smoke is happening in this direction, and the other one is the smoke is happening in this direction. So there are two directions against which the dispersion is happening, but the propagation is happening in only one direction. So what I'm trying to explain is the propagation and dispersion is two different concepts, or there are rather two different concepts. So do not intermingle them. They are very delicate, but you need to know what is what and what is not. I'm talking about dispersion or deviation. Deviation is only happening in the z direction and in the y direction, but propagation is happening in the x direction. So we are not concerned with the propagation, and hence there is no sigma y and hence there is no sigma x. It's only sigma y and sigma z. Since in the deviation is happening in the z direction is nothing but denoted by sigma z, and the deviation happening in the y direction, or rather the crosswind direction, is nothing but the sigma y. This is the vertical direction, this is the crosswind direction. Because in downward direction, the smoke is actually propagating. So this is the concept behind sigma y and sigma z, how it works, what is it actually. Now we will solve a numerical in the next tutorial rather, otherwise this tutorial will become enormously big. So till then, stay tuned for the next numerical and the numerical part of this chapter, because marks is important. Thank you.